Binomial distribution is a really useful way to find probabilities for certain events. So you can use binomial distribution for a scenario if it follows four criteria, okay? Firstly, there are a fixed number of trials, which we call n. We'll talk about this more in a moment. Two, there are only two possible outcomes, either success or failure. Three, there is a fixed probability of success which doesn't change, which we call p. And four, the trials are independent of each other. So one trial does not have an impact on the probability of another trial. Okay, so here's an example where we can use binomial distribution. Okay, so we're told a fair coin is flipped 20 times, and we need to find the probability it lands on heads 12 times. Okay, so we can use binomial distribution here because it follows these four criteria. So firstly, there are a fixed number of trials. In this case, a trial is when the coin is flipped. So it's flipped 20 times. So in this case, n is equal to 20. The second criteria is there are two possible outcomes, success and failure. In this case, success is when it lands on heads and failure is when it doesn't land on heads, so it lands on tails. The third criteria is there is a fixed probability of success, so it's a fair coin, so when you flip it, the probability of it landing on heads is 0.5, and this isn't going to change. And then the final criteria is the trials are independent of each other, so if we flip the coin and then we flip it again, whatever it landed on the previous time is not going to affect the probability it lands on heads the next time. Okay, so the trials are independent of each other. Okay, so in this circumstance, we're going to say that capital X is equal to the number of times the coin lands on heads, okay? This X here is the variable that we're measuring. So we're measuring the number of times the coin lands on heads. So X can be modeled using binomial distribution. The way that we say this, we say that X, and then we put a squiggly line, and then we say B, which stands for binomial, and then we say N P, like this here, where n is the number of trials and p is the probability. Now, as we've already talked about, n in this case is 20 because the coin is flipped 20 times, and p is the probability it lands on heads. It's a fair coin, so therefore this is 0.5. Now, we also have lowercase x, and this is the number of times that it lands on heads. In this case, it lands on heads 12 times, so lowercase x is equal to 12. So this here, we can write this as x can be modelled using a binomial distribution where n is 20 and p is 0.5, like this here. Okay, now this here is the formula for binomial distribution. Okay, so this here means the probability that capital X, which is the variable that we're measuring, is equal to lowercase x. In this case, lowercase x is equal to 12, and the probability is given by this formula here. This is given to you in the formula booklet. Weirdly, it's only given to you in the A-level section and not the AS section, but to be honest, you don't need to know this formula. I was actually tempted to explain how to use it and where this formula comes from, as it's really not that complicated, but you don't need to know it for your exams. The reason you don't need to know this formula is because your calculator can do binomial distribution for you, okay? I'm going to explain how to do this for the ClassWiz calculator, as I think that's a calculator the majority of students have. If you have one of the more complicated graphing calculators, you'll be able to do this as well. You'll just have to press different buttons in order to do it, okay? So on your calculator, if you press the menu setup button, it will come up with this screen here with all of the different options for the calculator, okay? Press 7 for distribution, and it comes up with this screen. Press 4 for binomial PD, and it comes up with this screen. Press 2 for variable, and it comes up with this screen. And insert your values for x, n, and p. So as we've already said, x is equal to 12, n is equal to 20, and p is equal to 0.5. Okay. Now, if you put these values in and then you press equals, it comes up with the probability. So in this case, the 4 decimal places, it's 0.1201. This is the probability that x is equal to 12. Okay, so here's the exact same scenario where a fair coin is flipped 20 times, but this time we need to find the probability it lands on heads 15 times, okay? So this is the exact same thing, so x can be modelled binomially where n is equal to 20 and p is equal to 0.5, but this time x is equal to 15. So therefore the probability that capital X is equal to 15. So you're going to do the exact same thing on your calculator, but you're going to sub in X is equal to 15 instead. And if you put this into your calculator to 4 decimal places, it's 0.0148. So this is the probability it lands on heads 15 times. Okay, now rather than finding the probability for a specific value, they'll more likely want you to find the probability for a group of values. Okay, so this is the same scenario where a fair coin is flipped 20 times, but this time we need to find the probability it lands on heads 9 times or less. Okay, so we're going to use the same binomial distribution model where n is equal to 20 and the probability is 0.5, but this time we need to find the probability that x is less than or equal to 9. Okay, now what this actually means is this is the sum of all of the probabilities for the values within this range. Okay, so the probability that x is less than or equal to 9 is the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2 all the way up to the probability that x is equal to 9. You could theoretically do this using the method we've already seen, but it would take you forever, okay? Luckily, your calculator can do this as well, okay? So on your calculator, do the same thing as before. Press menu setup to get this screen. Press 7 for distribution. And this time, on this screen, we're going to scroll down to get to this screen, and then we're going to press 1 for binomial CD, okay? Again, it comes up with this, press 2 for variable, and it comes up with the same screen that we've already seen, okay? So put in the value, so put in n, which is 20, put in p, which is 0.5, and put in x, which in this case is 9. And if you press equals, this is the probability that x is less than or equal to 9. So to 4 decimal places, it's 0.4119. So this is the probability it lands on heads 9 times or less. Okay, I just want to make one note quickly. So we have talked about how we can find the probability that x is less than or equal to 9 using our calculator. We found this value here. There is another way that you can find this value. So in the formula booklet on page 29, it has something called the binomial cumulative distribution function, and it has this massive table that goes over multiple pages. If you have the Pearson textbooks near you at the moment, in the Stats and Mechanics Year 1 textbook, it's on page 204 on there as well, and it goes over multiple pages. It's this massive table, and you can find probabilities for certain values of n, p, and x. And luckily, when n is equal to 20, p is equal to 0.5, and x is equal to 9, this is a set of values that you can use to find a probability in the table, okay? So the way that you use it is, firstly, you need to find the n is equal to 20 segment in the table. Now, at the top of the table, it has probabilities ranging from 0.05 to 0.50. So the probability that we have is 0.5. So we're looking at this column here, and then in the n is equal to 20 segment, we are looking for where x is equal to 9, which is here. And then if you look at this entry in the table, you can see that it says 0.4119, which is what we figured out using the calculator. So this is another way that you can find these values, is using this table. Now, I have to be completely honest, I never use this table. I just thought I'd mention it because it is talked about in the spec, and you do have access to this table in the formula booklet. I never use the table, firstly because I think it's more complicated, and secondly because you can only do it for certain values of n, p, and x, whereas the calculator, you can use any value of n, p, and x. So to be honest, just use the calculator. You don't need to worry about the table. Okay, so here's a few more examples. So here we have that the variable x can be modelled using a binomial distribution like this here, and we need to find the probability that x is less than or equal to 3. So in this case, n is equal to 10, and then p is equal to 0.2, and x is equal to 3. If you put these into your calculator to 4 decimal places, the probability is 0.8791. For this one here, told that x can be modelled using a binomial distribution like this here, we need to find the probability that x is less than or equal to 14. So here n is equal to 30, the probability is 0.45, and x is equal to 14. If you put this into your calculator, it's equal to 0.6448. Okay, so this one at the bottom is a bit different. So x can be modelled using this binomial distribution here, and we need to find the probability that x is less than 6. Note this inequality sign here, it's less than 6. It's not like the previous examples where it's less than or equal to 6, and this impacts what we do with the calculator, okay? So in this example, n is equal to 20 and p is equal to 0.3. Now you might be tempted to say here that x is equal to 6. However, this is only true when we have this inequality sign. However, this time, x cannot be equal to 6. So we have to change what we're going to do, okay? So the probability that x is less than 6, this is equal to the probability that x is less than or equal to 5, because remember that x can only be whole numbers, it can't be decimals, it can't be 5.5 for example. So x being less than 6 is the same as x being less than or equal to 5. So therefore this is what we're going to put into our calculator, x is equal to 5. If you put this into your calculator, it's equal to 0.4164. Okay, so here's another example that's a bit different, okay? So x can be modelled using this binomial distribution here, and we need to find the probability that x is bigger than or equal to 10, okay? Now this probability we cannot put directly into our calculator because this inequality sign is the wrong way round. We can only put this into our calculator if x is less than or equal to a particular value, but in this case x is bigger than or equal to 10. Just to note, if you have one of the graphing calculators, this is one of the advantages of the graphing calculator, is this probability you can put directly into your calculator. But assuming, like the majority of students, you're using the ClassWiz calculator, you can still do this, because what we're going to do, we're going to say that the probability that x is bigger than or equal to 10 is equal to 1 minus the probability that x is less than or equal to 9, and this here we can put into our calculator, okay? The reason this works, if you think about this grid here, so n is equal to 25, so x can be equal to any of these 25 values, okay? We're trying to find the probability that x is bigger than or equal to 10, okay? So this is going to be these values here, okay? So to find this probability, we can do 1 minus the probability that x is less than or equal to 9, because this means that this will knock out these 9 values here and just leave us with the probability that x is bigger than or equal to 10. This is why this works, okay? So this here, the probability that x is less than or equal to 9, we can put this into our calculator. So n is equal to 25, p is equal to 0.3, and x is equal to 9. If you put this into your calculator, this is equal to 0.8106 to 4 decimal places, okay? Now if you sub this in here, this is going to be 1 minus, and then the probability that x is less than or equal to 9 is this here, 0.8106, and if you put this here into your calculator, this is equal to 0.1894. So this is the probability that x is bigger than or equal to 10. Okay, so here's another example like this. So x can be modelled using this binomial distribution here, and we need to find the probability that x is bigger than or equal to 30. So the probability that x is bigger than or equal to 30 is equal to 1 minus the probability that x is less than or equal to 29, and this we can put into our calculator. So here n is 50, p is 0.5, and x is 29. If you put this into your calculator, so it's going to be 1 minus, and then if you put this into your calculator, this is equal to 0.8987 to 4 decimal places. And if you put this into your calculator, this is equal to 0.1013. So this is the probability that x is bigger than or equal to 30. Okay, so here's another example that's a bit different, okay, where we are told that x can be modelled using this binomial distribution here, and we need to find the probability that x is bigger than or equal to 10, but less than or equal to 13, okay? So like before, the graphing calculator can actually calculate this probability directly, but if you have the ClassWiz calculator, the way that we're going to do this, so firstly, let's ignore the part where it's bigger than or equal to 10. Let's first focus on that x is less than or equal to 13. So the probability that x is less than or equal to 13, so we can put this directly into our calculator, where n is 20, p is 0.45, and x is 13, okay? So if you put this into your calculator, this is equal to 0.9786 to 4 decimal places. Okay, so we've calculated the probability that x is less than or equal to 13, but now we need to calculate that it's also bigger than or equal to 10, okay? So let's consider the grid like we did before, okay? So we're trying to find where x is bigger than or equal to 10, but less than or equal to 13. So this is going to be this range here, okay? Now we have calculated the probability that x is less than or equal to 13, okay? So we have knocked out these values here because we have found where x is less than or equal to 13, okay? Now we need to find where it's bigger than or equal to 10, okay? So if we find the probability that x is less than or equal to 9, this will knock out these values here, and therefore we will just be left where x is bigger than or equal to 10 but less than or equal to 13, and then this will be the correct probability, okay? So what we're going to do, we're going to find this probability here that x is less than or equal to 9. So this is going to be the same before, where n is equal to 20, p is equal to 0.45, but this time x is equal to 9. If you put this into your calculator, this is equal to 0.5914. Okay, so therefore, to get the probability that x is bigger than or equal to 10 but less than or equal to 13, it's going to be the probability that x is less than or equal to 13, which is 0.9786, but we're going to minus the probability that x is less than or equal to 9, which is this probability here, 0.5914. If you put this into your calculator, it's equal to 0.3872. So this is the probability that x is bigger than or equal to 10 but less than or equal to 13. Okay, so for the rest of this video we're going to go through exam questions, but I want to mention one thing that's talked about on page 92 in the textbook, and they have this table here that I've just copied from the textbook. In exam questions, they can use certain phrases that mean different things in terms of the inequalities. So if an exam question says no more than 3, this means that x is less than or equal to 3, and we can put this probability directly into our calculator. If an exam question says at most 8, this means x is less than or equal to 8, and we can put this probability directly into our calculator. If an exam question says fewer than 10, this means x is less than 10 but it's not equal to it, okay? And as we've already talked about in this video, to put this probability into our calculator, we would need to do the probability that x is less than or equal to 9, okay? If an exam question says at least 7, this means x is bigger than or equal to 7, and as we've already talked about, to get this probability into our calculator, our ClassWiz calculator, we would need to do 1 minus the probability that x is less than or equal to 6, okay? And then finally, if an exam question says greater than 5, this means that x is bigger than 5 but not equal to it. Now as x can only be whole numbers, x being bigger than 5 is the same as saying x is bigger than or equal to 6, okay? And to figure out this probability, we would need to do 1 minus the probability that x is less than or equal to 5. Make a note of this because in exam questions, they may use these phrases and you need to know what they actually mean in terms of the inequalities. Okay, so here's a typical exam question where we're told a fair six-sided dice is rolled 20 times and we need to find the probability that it rolls on a 4 at least 5 times, okay? So in this case, we're going to say the variable x is when the dice lands on a 4, okay? So this is what we're actually measuring, okay? Now, we can use a binomial distribution here because of the 4 criteria as we talked about at the start of the video. There are a fixed number of trials because the dice is rolled 20 times, so in this case n is equal to 20. There are 2 possible outcomes, either success or failure. Success is when it lands on a 4 and failure is when it doesn't land on a 4. There is a fixed probability of success, so it's the probability that it rolls on a 4, which is going to be 1 over 6 because that is the probability that a dice lands on any side, 1, 2, 3, 4, 5 or 6, and the trials are independent of each other because it doesn't matter what the dice landed on before. If you roll the dice again, the probability of it landing on a 4 doesn't change, okay? So we can use binomial distribution here. So we're going to say that x can be modelled using a binomial distribution. So n is 20 because this is the number of trials, and the probability is the probability of a dice landing on a 4, which is 1 over 6, okay? Now we need to find the probability that it rolls on a 4 at least 5 times. So this is the probability that x, so it rolls on a 4 at least 5 times. So as we talked about, this is where x is bigger than or equal to 5. So we need to find this probability here. Now on our ClassWiz calculator, we cannot put this directly into our calculator. We need to do 1 minus the probability that x is less than or equal to 4, and this here we can put into our calculator. So n is equal to 20, p is equal to 1 over 6, and x is equal to, in this case, 4, okay? Now, if you put the probability that x is less than or equal to 4 into your calculator, so it's going to be 1 minus, and then this is going to be to 4 decimal places, 0.7687. And if you put this into your calculator, this is 0.2313. So this is the probability that the dice rolls on a 4 at least 5 times. Okay, so now we're going to go through some past exam questions, okay? If you want to have a go at any of the questions yourself, just pause the video before I go through the answer, okay? So for this question, we're told a fair 5-sided spinner has sides numbered 1, 2, 3, 4, and 5, and the spinner is spun once and the score of the side it lands on is recorded. And for part A, for 1 mark, we need to write down the name of the distribution that can be used to model the score of the side it lands on, okay? So we talked about this in the probability distribution video, so go back to that if you need a reminder. But this here, so the distribution is discrete because it can only land on certain values, so 1, 2, 3, 4, and 5. It can't be a decimal, for example, and it's also a uniform distribution. It's uniform because the probability of it landing on 1, 2, 3, 4, or 5, the probabilities are all the same because it's a fair 5-sided spinner, so therefore it's a uniform distribution. So it's a discrete uniform distribution. Okay, so the question goes on and it says the spinner is spun 28 times and the random variable x represents the number of times the spinner lands on 2, and part B overall is worth 5 marks, and for the first part we need to find the probability that the spinner lands on 2 at least 7 times, okay? So for this we can use a binomial distribution because it follows the 4 criteria. There are a fixed number of trials, it's spun 28 times, there are only 2 possible outcomes, success and failure. Success is when it lands on a 2 and failure is when it doesn't land on a 2. There is a fixed probability of success, which we'll talk about in a moment, and the trials are independent of each other. Okay, so x can be modelled using a binomial distribution. So n is the number of trials. The spinner is spun 28 times, so n is 28. Now the probability, so it's a fair five-sided spinner, okay? So 1, 2, 3, 4, and 5 all have the same probability of being landed on, and this probability is going to be 1 over 5, okay? So the probability is 1 over 5, or as a decimal it's 0.2, okay? So we need to find the probability that the spinner lands on 2 at least 7 times. So we need to find the probability that the spinner lands on 2, so this is x, at least 7 times. So x is bigger than or equal to 7. So to find this probability, we're going to do 1 minus the probability that x is less than or equal to 6. So this is going to be 1 minus, and then this here, we're going to put this into our calculator where n is 28, p is 1 over 5 or 0.2, and x is 6. And if you put this into your calculator to 4 decimal places, is 0.6784. And then if you put this into your calculator, it's equal to 0.3216. This is the probability it lands on 2 at least 7 times. Okay, and then for the second part of B, we need to find the probability that x is bigger than or equal to 4, but less than 8. Okay, so we're going to use the same binomial distribution that we used here. So let's ignore the fact that it's bigger than or equal to 4 first. Let's first find the probability that x is less than 8. So as we've already talked about, this is the same as the probability that x is less than or equal to 7, and this we can put into our calculator where n is 28, p is 1 over 5 or 0.2, and x is equal to 7. If you put this into your calculator, this is equal to 0.8182. Okay, so now let's consider where x also has to be bigger than or equal to 4, okay? So if we consider this grid like we talked about before, so n is equal to 28, so x is bigger than or equal to 4, so this is this here, but it's less than 8. Remember, this doesn't include 8. So this is this range here, okay? Now we have found the probability that x is less than or equal to 7. So this is the probability of these 7 outcomes here. So we've knocked out all of these values. So we need to get rid of these 3 values here. So these are the probability that x is less than or equal to 3. This we can put into our calculator. We just need to use the same up here, but this is now equal to 3. And if you put this into your calculator, this is 0.1602. So if we do this 0.8182, that is these 7 values here, minus the probability that x is less than or equal to 3, which is 0.1602. This will knock out these 3 values here and just leave us with a probability that's between 4 and 7. And if you put this into your calculator, it's equal to 0.6580. This is the probability that x is bigger than or equal to 4 but less than 8. Okay, so here's one final exam question for this video, okay? So for part A, we need to state one disadvantage of using quota sampling compared with simple random sampling for 1 mark. So we talked about quota sampling and simple random sampling in the data collection and sampling video back in chapter 1. So go back to that if you need a reminder. But a disadvantage of quota sampling is it's not random, or it's less random, or it's more likely to be biased. Okay, so the question goes on and it says, in a university, 8% of students are members of the university dance club, and a random sample of 36 students is taken from the university, and the random variable x represents the number of these students who are members of the dance club. And for part B, using a suitable model for x, we need to find, for the first part, we need to find the probability that x is equal to 4. So we can use a binomial distribution to represent this scenario, because it fits the 4 criteria. There are a fixed number number of trials because we have a sample of 36 students, so n is equal to 36. There are two possible outcomes, success and failure. Success is the student is a member of the dance club. Failure is that a student is not a member of the dance club. There is a fixed probability of success because 8% of the students are members of the dance club, and the trials should be independent of each other because the students are selected at random. Okay, so X can be modelled using a binomial distribution where n, there are 36 students, so n is equal to 36, and the probability, 8% of students are members of the dance club, so the probability is 8% or 0.08. And we need to find the probability that x is equal to 4. So rather than using the binomial CD, we're going to use the binomial PD mode on our calculator that we talked about before, because we have the equal sign here. So we're going to say that n is equal to 36, p is equal to 0.08, and x is equal to 4. So if you put this into your calculator to 4 decimal places, it's 0.1674. Okay, and then for the second part of B, we need to find the probability that x is bigger than or equal to 7. Okay, so the probability that x is bigger than or equal to 7 is equal to 1 minus the probability that x is smaller than or equal to 6. Okay, so we can put this into our calculator, use the binomial CD mode this time on our calculator because we have this inequality here. Okay, so n is equal to 36, p is equal to 0.08, and x is equal to 6. Okay, so this is going to be 1 minus, and then if you put this into your calculator, this is equal to 0.9778, and if you put this into your calculator, this is equal to 0.0222. So this is the probability that x is bigger than or equal to 7. Okay, so we are told that only 40% of the university dance club members can dance a tango. For part C for 1 mark, we need to find the probability that a student is a member of the university dance club and they can dance a tango. So we're looking for the probability of two things occurring at the same time. That a student is a member of the university dance club and that they can dance a tango. Okay, so the probability that they are a member of the university dance club is 8% or 0.08, and this is multiplied by the probability that they can dance a tango, which if they are part of the university dance club, the probability that they can dance a tango is 40% or 0.4. Okay, and if you put this into your calculator, this is 0.032. So this is the probability that a student is a member of the university dance club and they can dance a tango. Okay, so the question says that a random sample of 50 students is taken from the university, and we need to find the probability that fewer than 3 of these students are members of the university dance club and can dance a tango for 2 marks. Okay, so I think this is quite a difficult question, but I think if you don't know how to do it, once I explain it, hopefully it will make sense. Okay, for this we are going to use another binomial distribution. Okay, so we need to find the probability that fewer than 3 of these students are members of the university dance club and they can dance a tango. Okay, so we're going to introduce a new variable here. It's not going to be x like this up here. Let's say that this is y. It can be anything really, but let's say it's y, and y is the number of students who are members of the dance club. So remember, x was the number of students who are members of the dance club, but y is the number of students who are members of the dance club and can dance the tango. Okay, so it's this part added on as well, because this is what we're looking for, the probability that fewer than 3 of these students are members of the university dance club and can dance a tango. So y can be represented by a binomial distribution where n, so we've taken a random sample of 50 students, and the probability that they are a member of the university dance club and can dance a tango is this here that we figured out in part C, is 0.032. So this is the binomial distribution for this situation. We're finding the probability for students that are members of the university dance club and can dance a tango from 50 students. So we're going to use this binomial distribution here. Okay, now we need to find the probability that fewer than 3 of these students, so we need to find the probability that fewer fewer than 3, so remember this is y is less than 3, remember what fewer than means. So we need to find the probability that y is less than 3, okay? So this is equal to the probability that y is less than or equal to 2, and this we can put into our calculator where n is 50, p is 0.032 and x is equal to 2. And if you put this into your calculator to 4 decimal places is 0.7851. This is the probability that fewer than 3 of these students are members of the university dance club and can dance a tango.